Hi, this is Steven, and this tutorial is about connecting an I2C sensor to the ESP32 and control it from or read it from the Lego Mindstoms side. What I have here is a setup. On the left side I have the Lego Mindstoms IDE, on the right side the LMS-ESP32, and on the small camera you see an I2C device, which is a joystick. It can be moved in X and Y direction. You can even press it. So it has 3 registers. So an I2C device has an address at which you can select it and at which you can send or read commands. The way it works on the ESP side is that you need an I2C device, so that's imported from machine, and you need the pins to which you connect the I2C device. So let's see how that works. I will import these things first. Now I can create an I2C device based on this I2C class. The first argument is there are a number of I2C devices present in the ESP32. We use the first one. And then you have to select 2 pins, the data SDA, this is on pin 5, it can be seen on the documentation, and the clock pin of the I2C is on pin 4. Once I've done that, and I connected to this cable, I connected the I2C device to the I2C port of the ESP32. These I2C devices are made by M5 Stack. I will show you a link. They are really neat because they have holes that are compatible with Lego, so you can mount them on your Lego builds. So now we have this I2C initialized. I can see whether it's working by doing a scan. What a scan does, it tries to find devices on the I2C bus. In this case it finds one, and it shows the address of the device it finds. In this case, this joystick is a very simple I2C device in the sense that it has only 3 registers for the X, Y and the button pressed register. So if I use I2C read from, then the first argument is the address of the device, that's the 82 that I just scanned, and the number of bytes I would like to read. So I read 3 bytes, then I get a weird looking thing because it's a byte array. And a byte array, I can put it in a variable, and the variables now act like an array. So if I take 0 or 1, I get the X and the Y, and the second, the 2, that's the button pressed. So what I could do here, I could make a function to read a joystick. It has no arguments. So I take this, and of course I have to initialize the I2C first. So I have to put this line also in the main program. So it initialized the I2C bus on these 2 pins. And it can read now from that bus, from address 82, 3 bytes. And then I know that the X is Q0, the Y is Q1, and the button you won't use in this example, but for the sake of complete I will do it. So and now I return those 3 variables. So we can check how this function works. If I now do rejoy, I should see, so now you can see if I move the X direction, if I move to the Y direction, you see the Y varying, and if I try to press, you see 1 or 0. So I can read these 3 things. Now on the left side, as I already explained, there's my Lego Mindstorm, which I have to switch on again. It's annoying, it always switches itself off after a few minutes. But I switch it on, connect to it, and I have here some initialization of the UartRemote. The hub I will use for buttons and for the display. So that's about it. I connected the LMS-ESP32 to port D, so that's the reason I initialize UartRemote with D as argument. So let's do this. And now I would like to do a call from the Lego side to the LMS-ESP32 to read this joystick. So that's rather easy. We have already initialized the UartRemote, so we add this function to the UartRemote. Because the function returns values, we have to define how these values are passed to the other side. We choose wrapper. And then the only thing we need to do is loop the UartRemote so that it waits for incoming calls, and as soon as one of the calls is rejoy, it will return the joystick. So let's start this. So it's looping now. What I can do now here is call read joy. And there we are. So what we now achieved is, from the Lego Mindstorm side, I can read the values of this I2C joystick. So if I move the joystick, you see that the values are passed to the Lego side. So that's great, because now we can do something with it on the Lego side. So let's draw a pixel on the screen. That so first I should have to figure out how. What was the command again? Display. So I can display any show. If I do this, I get an A, but if I do a space, I can wipe the screen. So I wipe the screen. So I make a function to plot a pixel on X and Y. So first I wipe the screen, and then, if I correctly remembered, you can use pixel. And there's 3 arguments, X, Y, and the intensity of the pixel. So this is correct. So I can now plot pixels. So what I do is just use this function, and as an argument X, Y, let's say 9, the most intense pixel, and that's it. Okay, now I'm going to do a while loop while not the left button pressed. So this button left was pressed. What should I do? I should call the joystick. So let's call it joy. So we call the joystick by using this call to the remote side. So the Lego calls the ESP32 to collect the coordinates of the joystick. And then we need to plot the pixels, and we need to, because the coordinates of the pixels are between 0 and 5, so it's 0 until 4, and the coordinates of the joystick are between 0 and 255. So roughly I will divide the joy 0, so it's X coordinates, I will divide it by 50, so the 2 slashes is an integer division, and just to be safe, I do a modulo 5, so it will always between 0 and 4. And I do the same, but then for the y coordinate, so that's the 1 on the array, and that's it. And maybe I should, okay, that's already taken care of. And then just for it runs a little bit smoother, it will sleep 50. I already have this, I guess. Now let's do it again. I'm not certain that I have imported the time, so let's see. This is working. Oh, let's see whether the function is working. So I do plot pixel 1 1 2 3 4. So this is working, and then hopefully this also works. So let's see. Oh, there's something wrong. Okay, let's do it again. You see that the advantage of this Tony, that you really can interactively test your program. It really makes things much easier. Now, well, so the right direction is working correctly. The X, it's mirrored. So probably the screen is the other way around. So what we can do is subtract this value from 4. So then we get a 0 if it's 4 and a 4 if it's 0. So run this again. And now we have a joystick that, well, a pixel on the Lego Mindstorm that follows the joystick. We just connect it to the ESP32 and it's communicating through the UartRemote library to the Lego Mindstorms. And it's really smooth, as you can see. So this is a great example where you can try. You can hook up any I2C device as long as it is powered by 3.3 volt and as long as the cable that you are using is compatible with the Grove connector on the LMS-ESP32. So enjoy and see you next time. Bye bye.